In this concept, we're going to talk about the coordinate system. And the coordinate system includes the concept of a coordinate plane, which is the intersection of two perpendicular number lines. So remember, we talked about number lines in the very beginning. One of the very first concepts, if not the first concept actually, was about number lines. And we talked about how a number line is a visual representation of the numbers, right? With 0 in the middle at the origin, and then, the positive numbers go towards the right, the positive side, and then the negative numbers go towards the left, right? So 1, 2, 3, etc. -1, -2, -3, etc. So this is essentially a representation of numbers in a single so-called dimension. Okay, but what happens if I add another number line perpendicular to the first one, right? And again, this way would be positive, right, with 0 at the center here for that second line as well. And then this way would be negative. So this would be positive, right? And then going down here, this would be negative. So now I can actually represent pairs of numbers on these two lines, okay, as opposed to a single number. So now I can represent ordered pairs, right, so-called ordered pairs, and we'll talk about them soon. So this is essentially what we have here, right? We have an x, for example, and a y, right? And both of these are variable, so they could be anything. We could choose a point, and again, the point is going to be made of an ordered pair, which is one coordinate for x, one coordinate for y. And that's going to show us, or it's going to allow us to know where that point should be placed on the graph. Okay, or on the coordinate plane, I should say. So again, to recap x and y coordinates, so x and y in this case are coordinates which are ordered pairs in the form of xy used to show the position of a point in a coordinate plane. Okay, so this is the coordinate plane. The horizontal value, which is x, okay, in the pair of coordinates, essentially tells you how far along the x-axis the point is from the origin. So you start from the origin, which is 0, 0, right? 0 on x and 0 on y. And then let's say the x value is 2, right? So you go 2 units from the origin. So 1, 2. So this would be a point for x. And let's say you had like a y value of 1, right? So you would go up from the x, right? 0y, you would go up to 1, right? And the intersection of these two coordinates is where the point would be, which is right here, right? So this is the point, for example, 2, 1, right? So again, to recap for the y coordinate, so the vertical y value in the ordered pair of coordinates tells you how far up the point is from the origin along the y number line. Okay, and for the y dimension, the coordinate, or the value that represents the y, the coordinate in the ordered pair for y, is positive if it is above the origin. Okay, so if it's above, then it's positive, just like I explained up here. If it's below, it's negative. If it's below the origin, it's negative. Let's look at an example. So I already showed you 2, 1, right? So 2 on x, and then 1 on y, and then just draw their intersection. Let's look at another example. Let's look at 4 and 2. So that would be 4 on x, right, and 2 on y, and then this would be the point. Okay, how about -1 and -2? So you will go to the negative side on x, right? This is -1. And then for y, you would go again towards the negative side, and this would be -2. So -1 and -2, and then you would again draw the intersection. So this is -1, -2. Okay? Now another point to keep in mind in regards to the coordinate plane is that the x-axis and the y-axis divide the coordinate plane into 4 so-called quadrants. Okay, so 4 quarters, but we call them quadrants. The x-axis is this horizontal line. The y-axis is the vertical line. And the signs of the coordinates for the different quadrants are important to be kept in mind, right? So quadrant 1, you have both the x and y values are positive, right? So they're both positive. Said another way, if I gave you an ordered pair with 2 positive numbers, you know that that is going to be referring to a point that's in quadrant 1, right? Let's say I gave you, 2 and 5. You know this is going to be located in quadrant 1 because both of them are positive. And this can only happen if this point is located in quadrant 1. Okay, let's say I gave you, 20 and 15. Same thing. You know this is going to be located in quadrant 1. Okay, in quadrant 2, the x-axis is negative while the y-axis is positive. So quadrant 2 is to the left, side of x, right, which is the negative side. But it's still, above the horizontal for y. It's above the 0 for y, so it's positive for y, right? So quadrant 2 has negative x and positive y. Said another way, if I gave you a pair of numbers where the first number is negative and the second number is positive, you know that it has to belong to quadrant 2. You know that that point that is referenced by that ordered pair has to lie in quadrant 2. So let's say I gave you -5 and 3, right? You know that this has to be in quadrant 2 because the x is negative, the y is positive, etc. In quadrant 3, both the x-axis and the y-axis are negative, right? So if I gave you 2 numbers that were both negative, you know they would belong to quadrant 3. If I gave you -4 and minus whatever, 5, right? -4 and -5. You know that this point is going to have to be in quadrant 3. And in quadrant 4, the x-axis is positive while the y-axis is negative. So quadrant 4, you have positive x and negative y. So an example of a point in quadrant 4 would be 2 and -4, for example. Okay? Let's look at some more examples. Identify which quadrant the following points lie in. So 2 and 3. Right? So remember, both of them are positive, so that would be quadrant 1. Right? And in fact, if we tried to graph them, or place the point, right, we have 2, so 2 on x and 3 on y, right, and then just make the intersection. So this is, 1, 2, and this is, say, 1, 2, 3. Okay. Minus 2, minus 5. So both are negative, both coordinates are negative, so this is going to be in quadrant 3. And again, if you try to graph it, so minus 2 is 1, 2, so this is minus 2, right? Minus 5 is 1, 2, 3, 4, minus 5, right? This is minus 5. And then just draw the intersection of these 2 points, and this is quadrant 3. Okay, we've got some exercises here. Please pause the video, work on these, try to plot the points, and come back for the solutions. Okay, so we want to plot the following points and identify what quadrant they lie in. So first off, we have 5 and minus 3. So let's draw a quick coordinate plane. Actually, I need more space up here, so let's do this. Let's just draw it here. So I have 5 on x and minus 3 on y. So let me count 5. So plus 5, right? So I'm going to go in this direction, right? So I'm going to count 1, 2, 3, 4, 5, right? So this is 5 on x plus 5. And then I want to count minus 3 on y, so I'm going to have to go in this direction, right? So minus 1, minus 2, minus 3. So minus 3. And then all I need to do is just find the intersection. So this is 5 and minus 3. And this would be quadrant 4. Okay, 0 and 3. So on x, it's telling me to move 0. So I'm going to start from the origin, and I'm going to move 0, which is not moving at all. So the x value is going to be here at the origin, the x value. Or it's going to be on 0 for x, the 0 on the x number line, right? Right? The y value is going to be plus 3, so I'm going to count this way, right? So 1, 2, 3. Right? So the point is going to be 0 on x and up here 3 on y, which is going to be right here actually. It's going to be on the y-axis. This is also known as a y-intercept, right? So an intercept is a point that literally intercepts with one of the two axes, whether x or y. In this case, the point happens to intercept with the y-axis because it lies on the y-axis. Right? Minus 12 and 8. So let's draw it out here. Right? X, Y. So minus 12, right? So I want to move in this direction on x. So minus 1, minus 2, minus 3, minus 4, 5, 6, minus 7, minus 8, minus 9, minus 10, minus 11, minus 12. And I want 8 on y, so I'm going to be moving, so plus 8, I'm going to move it up in this direction. So 1, 2, 3, 4, 5, 6, 7, 8. And then just draw the intersection. Right? So this is minus 12 and 8. And this is in the second quadrant, right? Q2, because the x value is negative or the y value is positive. And last but not least, we have 2 and 0. So plus 2 on x yeah, let's make this more straight up. Okay, so plus 2 on x, so I'm going to count this way, right? Positive direction for x. So 1, 2, and then 0 on y, so I'm not going to go up at all, right? I'm going to stay on the x-axis. And this is actually this is actually known as an x-intercept. Okay, so up here, this was a y-intercept, and here I have an x-intercept because it intercepts the x-axis. So you can't really say that it sits in any specific quadrant. It sits on the axis. Okay, hopefully this was clear. This is it for this concept. See you in the next video.